Hello, this is Ms. DB, and in this lesson we're going to talk about Chapter 7, Section 2, which is on ratios in similar polygons. So using what we learned in the last lesson for figures. We are going to identify similar polygons and apply properties of similar polygons to solve problems. Vocabulary today is similar, similar polygons, and similarity ratio. All right, here's the first word is similar. Figures that are similar have the same shape, but not necessarily the same size. So one will be bigger than the other generally. The symbol for similar is this little squiggly line. If you remember the symbol for congruent, it's like that, but there's only one of them. So here's an example. We have triangle 1 and triangle 2. Triangle 1 is similar to triangle 2. So you would write triangle 1 is similar to triangle 2. If you are typing in Word, you have to type the word triangle out because you won't find that little symbol easily. You can find this little squiggle similar symbol if you go to Insert Symbols. It's one of the first ones that shows up under the Math section. Otherwise, it'll be on the worksheet and you can copy and paste the figure, the symbol that I've used. Now in this one, triangle 1 is not similar to triangle 3. We don't usually even write that triangle 1 is not similar to triangle 3 with symbols like they did here, but you could. Generally, we will only write the similarity symbol if they are indeed similar. So you can see that in triangle 1, it looks like a isosceles triangle, and triangle 3 looks like a right triangle, and does not look isosceles, looks maybe scalene. So those are not similar to each other. All right, so here's our definition. Two polygons are similar polygons if and only if their corresponding angles are congruent. All the angles will be congruent and their corresponding side lengths are proportional. So here's two figures. We have two quadrilaterals. We can see that angle A is congruent to angle E. They're both right angles. They're congruent to each other. So you can write a statement that says that. You can see that angle B is marked congruent to angle F, so you can write that like this one. Angle, what's next? C. Angle C has two angle marks, and so does angle G. So angle C is congruent to angle G, and angle D is congruent to angle H. So the corresponding angles are congruent. Also, their side lengths are proportional. So here's side AB. It would be proportional, or you're going to use it in a ratio to side EF. So you write AB over EF. Then BC over FG. Then CD over GH. And then last side is DA over HE. And if you plug the numbers in, 6 over 12, 5.4 over 10.8, 4 over 8, and 5 over 10, all of those ratios reduce to the same thing. They all reduce to 1/2. So that means they're all proportional to each other. They all reduce to the same ratio. We right here can write that quadrilateral ABCD is similar to triangle EFGH. Note that the A and the E are the angles that go together, and B and the F are the corresponding angles, and C and the H, and I mean C and the G, and then D and the H. So you have to write these in the correct order. That's called a similarity statement. Okay, this says identify the pairs of congruent angles and the corresponding sides. You have to do a couple of these on your assignment today. So the pairs of congruent angles, let's see, it's nice to start with the right angles that are marked. So we know that N is congruent to angle Q, so you write that. And the angle P is congruent to angle R. We know that because they're both marked 63. Now, because of the third angles theorem, we know there's 180 degrees in every triangle, so we can take 180 minus 90 minus 63, and we'll find that angle M is also congruent to angle T. So remember, if two angles of a triangle are congruent to the corresponding two angles in the other triangle, then the third angles also are congruent. So angle M is congruent to angle T. Now we got to do the sides. Now for sides, remember that you're going to write two letters, and we're going to write them as a ratio. So if you're starting with the big triangle, then do that for every one of your ratios. So side MP corresponds to side TR. So MP over TR, and then you can substitute the numbers in and see that that will simplify to the number 2. And then MN corresponds to, here's MN, to TQ. So 2 over 1 equals 2. And then finally NP over QR, and that also simplifies to 2. So if they had asked you to figure out whether or not these were similar, then you would say yes, they are, because they all simplify to the same ratio. In this one, they said that these are similar. Now figure out the corresponding angles and sides. Okay, here's another example. Same type of thing. You're going to list which angles are congruent to which. Again, we'll use the third angles theorem. And then you're going to write the sides as ratios. So again, if you're starting with this triangle, then you'll keep that ratio the same each time. So the length of AB over the length of JG, those two sides go together because they're opposite the angle 59. And then side BC is opposite angle A, which is our, that's the third angle, and opposite angle J would be 3, so we have 6 over 3, so BC over GH, and then the last side is, well, it's the hypotenuse of the right triangle, AC over JH, and you put those numbers in, and all of these simplify to the same ratio. Sometimes the ratio that you simplify will be a fraction. It'll be a fraction if you take the little one to the big one. If you take the big one to the little one, then it'll be a number greater than 1. So it depends on which order you do. They're both correct. So the similarity ratio is the ratio of the lengths of the corresponding sides of the two similar polygons. And again, if you write your ratio from the little to the big, you'll get a fraction. If you write your ratio from the big to the little, you'll get an integer number, or not necessarily an integer, but you'll get a number greater than 1. And both are correct. You can do either way. Both of those similarity ratios are correct. Now, if they tell you, I want the similarity ratio from triangle ABC to triangle DEF, if they tell you what order they want you to do, then you only get one answer. But if they just give you two figures and say write the similarity ratio of the figures, then either one is correct. A similarity statement is like writing a congruent statement. You have to write the vertices in the correct order. Corresponding angles have to be placed in the same order when you list your vertices. So this one says to first determine whether or not they're similar. If they are similar, you write the similarity ratio and a similarity statement. So similar figures have all angles congruent, can't really tell in this, and they have all sides proportional, so have the same ratio. So what you're going to do is see if the angles are congruent. Oh, did they say it was a rectangle? Oh yeah, they are rectangles, so then we know that all the angles are congruent and because they're all 90 degrees. So that part's done. Now we have to check and see if the sides have the same similarity ratio. So does side BC over FG, that ratio is 9 to 6. Now that ratio would be the same as AD over EF, because it's a rectangle, and one of the properties, one of the properties is that opposite sides are congruent. So 9 over 6 simplifies, divide both by 3 to 3/2. Now check the other side, BA over FE. And that again would be the same as CD over GH. And that is 6 to 4, so you have to see if that simplifies to 3 over 2. Divide them both by 2 in that case, 3/2. They have the same similarity ratio. So therefore, these are similar rectangles. So we took care of the first part of this, which is to determine whether or not these figures are similar. Then the last part is to write a similarity ratio. Similarity statement. The similarity statement, whoops, I went forward instead of back. I was going to show you the picture of those two triangles again. Right there. So, stop moving. Okay, so if I start with A to B to C to D for rectangle, this first rectangle, then A corresponds to E and B corresponds to F. So they actually wrote these in the correct order, and you just need to put a similar sign between them. Now often they won't have this listed out for you, and then you just say, okay, A has to go first, and E has to go first, and B has to go second, and F has to go second, and you'll just line them up, start in the same place, and go around. Make sure that the corresponding angles are listed in the same spot when you write them. Okay, we did that. Okay, here's a different example. It says, determine whether the polygons are similar. If so, write the similarity ratio and a similarity statement. This is not these two triangles. So we have here triangle, let's call it PQR, and we want to see if it's similar to this one. So first of all, this is 36 degrees. I don't know this angle, and I don't know this angle. This is 62 degrees. I don't know this angle, and I don't know this angle. However, we do know that this is an isosceles triangle because it's 10 and 10. So base angles are equal. So we're using all the stuff that we learned last quarter, and we're applying it to these problems. So that means I know there's 180 degrees in a triangle. I've already used up 36 of those. So 180 minus 36 is 144. Well, that's shared between these two. So if I just divide by 2, I will find the measure of P and of angle R. So that's 72 degrees. So this one's 72, and this one's 72. Did I do that right? Because it's not looking good then. 7 minus 3 is 4. Now over here, this is marked 62. I really don't have to go any farther. These are not similar because 62 is not one of the angles over here. I could go farther, and I could say, well, then this one's 62, and then I could take 62 plus 62 is 124, and I could subtract that from 180 and find, but you don't have to do all that because they're not similar. So therefore, you can just say that they are not similar. It's probably easier to type that than it is to do the not similar symbol. Okay, how about these two? Let's determine whether or not they're similar. And if so, then we'll write the similarity ratio and the similarity statement. So we know that angle M is congruent to angle N. We know that angle L is congruent to angle P. By the third angles theorem, you know that angle J would be congruent to angle S. So all the angles are congruent to each other, so that we took care of that part. Now we have to do the similarity ratio. Now make sure you do corresponding sides. I always like to start with the hypotenuse. So I'm going to do the big triangle to the little triangle, 35 or 75 over 30, and I'll simplify that. Let's see, they both can be divided by 5. So that would be 6. 75 divided by 5 is that 15? Yeah, 15. Now I can see, oh, there's something else I could simplify. I could divide both of those by 3. If you have a calculator that does fractions, you can even just type the fraction in, 75 over the fraction key, 30, and then hit equals, and it'll simplify it for you. So these simplified to 5/2. Now I have to check and see if the other sides also simplify to 5/2. So let's do opposite angle L. The one with one angle mark is 45. Opposite one angle mark over here is 18. Now I'm going to simplify that fraction and see if I get 5/2. These are both divisible by 9, and that indeed does equal 5/2. So that's good. And then one more side to check. Opposite the angle with 2 marks is 60, and opposite the angle with 2 marks is 24. And I want to see if that simplifies to 5/2. Let's try dividing both of these by 12. 60 divided by 12 is 5. 24 divided by 12 is 2. So they are indeed similar. Once you determine they are similar, this is the similarity ratio right there, 5/2. That's what I got each time. That's the similarity ratio. The statement is, they kind of already got it done. Triangle J, if you start with J, L, M, would be similar to triangle O. They got this lined up wrong. These two triangles are similar, but not in the way they wrote them. So the similarity statement has to go in the correct order. Let's start with J like they did, L, M. You would say it's similar to triangle. All right, that's got 2 marks, so we have to put S first. S, and then they went to L, which had 1 angle mark, and that's P, and then they went to N. That would be a similarity statement. Correct one. Now, that's not the only similarity statement. You could start with M and go MLJ, and then over here you'd have to go similar to triangle N. I can't remember which order I went. NPS, I think. So you just have to make sure your corresponding angles are listed in the same spot when you write your similarity statement. And they're just going to go through the same thing I did. Okay, when you work with proportions, be sure the ratios compare corresponding measures. Always make sure that you put the corresponding parts together. In this example, you're going to find the length of a model. So we're going to set up a proportion. We will use the length of the racing car over the length of the model equals the width of the racing car over the width of the model. So in this one, they're putting the racing car on top of each, and then they're doing model on the bottom of each ratio. That's not the only proportion that you could do to get this to work correctly, but it does work. And then you use cross products like we learned about in 7.2, and you find x. So in this one, 17.5 equals the length of the model. Okay, so you've already worked with proportions, so I don't think you'll have a problem with doing those applied problems at the end. All right, let me know if you have any questions. Thank you very much, and have a great day.